Quickie, which freezes faster, hot water or cold water? What if I told you it was hot water? Yes, under the right conditions, hot water can freeze faster than cold water. Sometimes. Maybe. Erasto Mpemba was making ice cream with his classmates in 1963 at Magamba Secondary School in Tanzania. He noticed that the hot mixtures actually froze faster than the cold ones, even when they were put in the freezer at the same time. He told his teacher, who was skeptical, so they did an experiment. Put 2 glasses, one warm and one just having been boiled, into a freezer. Quite often, the one with the highest temperature was the first to freeze. It's a phenomenon observed by historical figures from Aristotle to Francis Bacon to René Descartes, although this was the first time it was experimentally observed. And scientists still aren't sure why. In fact, there wasn't any good explanation until 2020, when Avinash Kumar and John Beckhofer of Simon Fraser University examined temperature changes in fine glass beads and observed the same effect, without having to observe a state change. Temperature change isn't a one-dimensional journey from hot to cold. We live in a 3-dimensional world after all, and there's something about warmer molecules that cause heat to radiate at more acute angles. That causes it to lose heat faster and thus cool down faster. They then act through convection to cool their neighbors. And that apparently explains why, interestingly, hot water freezing tends to form hexagonal crystals more reliably than cold water, which more often forms columns, plates, and needle-shaped structures. But it's so hard to study because the magnitude of the effect, or indeed whether it happens at all, has to do with all sorts of confounding factors, such as impurities in the water, which leads some scientists to continue to doubt if the effect is real at all. Sounds like a future Nobel Prize for the person who can figure it all out. Ear monitors and eyeglasses should learn to live together in harmony.